Good afternoon to all the participants. We have our next speaker with us, Mr. Anil Kumar Sharma. So before starting the session, let me give a brief introduction about our next speaker. Mr. Anil Kumar Sharma has completed BTech with Electronics and Communication and MTech in Microelectronics from Rajiv Gandhi Technical University, Bhopal. He worked in industries like Integrated Microsystem and Quantum-Wise Software Technical Specialist for 7 years. He provided training on nanotechnology simulation software like Quantum ATK in different renowned institutes like IIT Bombay, IIT Hyderabad, IIT ISM Dhanbad, NITTR Chandigarh, IITM Gwalior, Calcutta University, CSIU Chandigarh on Quantum ATK software. Now he is working in Impulse Technology as a managing director. He is currently working on Nanotech software from Nano Academic Technologies. Today, he will show presentation and demonstration on nanomaterial and nano device modeling and simulation using Nanotech software from Nano Academic Technologies. Welcome, sir.
Very good afternoon. I would like to thank Dr. Sanju Tanwar, who has given this opportunity to explain this simulation software. So now I would like to share my screen and show you some presentation and live demonstration on this Nanotech software. So I hope my slide is visible to all the participants and I am audible to all the participants.
Yes,
properly.
sir. Yes. Yes, sir.
Thank you. Let me continue. So very good afternoon to all the participants for joining this beautiful session. So today I will discuss that what about nanomaterials modeling simulations, how it can be done easily and we can predict the properties of nanoelectronics materials and devices. So we are the distributor for Nano Academic Technology. That is basically a Canadian company. It provides a software where virtually nanomaterial and nano device can be simulated. Now this Impulse Technology have many partners related to simulations industries. So today we will discuss about this Nano Academic Technology that basically provide the nanoelectronics based material and device simulation software where you can simulate the atomic structures, molecular structures, crystals, devices, all those things can be simulated along with the quantum transport calculations. And if you are working on only material simulation, we have a software on cloud platform. As you know, in this COVID time, many of the peoples are working at home. So we have a software for material simulation on cloud platform. Suppose you do not have a cluster or workstation facilities. In that case, cloud software is also we have that is called Exabyte IO. That is available on Google and Amazon servers. So you can run the calculations of material simulation on Amazon and Google server. And for organic semiconductor device simulation, we have one company that is called Fluxim that can work on organic and perovskite kind of organic solar cell and LEDs applications. So these are three different companies that we are the partner with them and we are presenting in India. Today we will discuss about Nano Academic Technology, that how easily you can do, what properties you can calculate and how you can simulate the materials and devices. Now, we goes to the next slide. So Nano Academic Technology is basically a Canadian company. It develops the software for atomic state electron transport calculations. This company is also working earlier with Quantum ATK because in the beginning there are 4 founders. They working together in 2008 and after certain period of time they splitted and they have founded this new Nano Academic Technology company in 2008 and they are working from since long and developing the similar functionality with quantum transport materials and device simulations. So this nano decal is basically LCAO implementation, linear combination of atomic orbital with density functional theory and non-equilibrium green functions. NEGF quantum transport, first principle ab initio modeling is there. Using that, you can calculate the materials, crystals, and two probe and multi-probe device structures. It can work in variety of applications like molecular electronics applications, spintronics device applications, semiconductor nanoelectronics applications, nanowires, sensors, carbon nanostructures, metals, contact interfaces, heterostructures, phonon vibrational property calculations, all electronics and transport quantum transport properties for the material and device can be calculated. I will show you the live demo of the tool, that how you can do the modelings, how you can set various parameters, and how the properties of various material and device can be calculated. That live demo will be shown after this presentation. Now, this software is dedicatedly designed for all nanoelectronics based applications. Either you can work on spintronics devices where transmissions related applications, some spin movement, spin up, spin down calculations, or some metallic tunnel junctions kind of applications, nanowires.
Excuse me, sir.
Yes,
Please make it full screen, sir.
1 minute. Now, can you see full screen?
Sir, make it in slide mode, sir.
It is already in slide mode. It is already in full screen. From my side, it is already in full screen.
PPT mode, sir. Presentation mode, sir.
Sir, in the lower taskbar, you can press the button where the zoom is coming in the lower side. Minus plus buttons are coming.
1 minute.
Yeah, on this your page at the lowermost right hand side, there is coming minus and plus buttons for zooming. Near to that, there is a button of presentation.
In my side, there is no such button.
So then, sir, you can while presenting this, you can choose the full screen. Might be sometimes there comes a problem. Close this slide, present again, and choose the full screen presentation.
1 minute.
Yes, sir.
हाँ जी सुनील भाई, मेरा आपसे रिक्वेस्ट ये है भाई कि हमारा जो
Please, the participants are requested to please keep their mic on mute.
Now is it okay, ma'am?
So still there is a full screen is not visible. You can either press F5 or you can go to the slideshow. F5 button sometimes works as a resume slideshow on the upside. Yes, on resume slideshow you can click.
1 minute, 1 minute.
Yes, sir.
हाँ जी
All other participants are requested to please keep their mic on mute.
हाँ जी बोलिए सुनील जी बोलिए। हाँ 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 508p।
I have already, ma'am, click on full screen mode.
तो ये सब्जेक्ट
Okay.
हमारा
Can you see my full screen mode now? I've already pressed. I find that button and it is already there.
But sir, still the full screen is not there. Though the slides are visible.
Sir, click on the from beginning button. Hopefully, we will see your complete screen.
Okay.
Yes,
Okay.
in the slideshow. Yes, sir.
वो
So in the slideshow, either you can press from beginning, just on the left hand side.
But I already pressed. I already found that option, enter full screen, and I clicked on that. Now it is asking about exit full screen mode.
Okay, on your PC, you are seeing just one slide.
1 minute. Let me close all other slides. Is it okay now?
So slide is visible, but screen is not seen as a full screen mode. I don't know why there is a problem.
From my side, I already click on that option, full
Okay,
screen
and
option.
here on your PC, you are seeing just one slide.
Yes, I am seeing only one slide in my system.
Okay. From our side, we are seeing all the slides in the left hand panel. Okay, and it is in the non full screen mode.
Excuse
Okay.
me.
Yes.
There you see in the lower portion there is 3 points is present in your slide. See at the lower portion. Just click the third one.
So
Which
in the
one?
in the lowest bar where it is
There is
showing
65% is
slide
showing
one of
near to
where it is. Please,
yes,
please
near to
participate.
65%. Click that thing.
I cannot find that 65%. I do not see it.
It is showing in your slide. Why not you are searching your slide? Just below to slide there is present.
Might be there is some problem during the presentation. Still, sir, you can continue. We can visualize the slide. It is visible. Okay.
Okay,
You
actually,
can
I
continue with
cannot
the
find
topic,
any
sir.
percentage option is not there in my side.
Okay, sir. Okay, sir, you can continue. It is still
Even I will
visible.
give you the live demo of the tool. That time you can see the software. Whenever I will do the lab demo on the software, that time it is more important. It is just only presentation that will show you that what capability is there. But once we will do that live demo, I will take some materials and show you how to set up the parameter and calculate some output. That's very important after this presentation. So now you can see my screen. No?
Yes, sir.
Fine. So now let me continue. So basically here you can simulate all type of applications. It can simulate the molecular materials, crystals and nano devices, spintronics devices also, semiconductor devices also, virtual crystal approximations, topological insulator, MOS devices, silicon PN devices, graphene and other one-dimensional, two-dimensional materials can be simulated, transmission spectrum, graphene, carbon nanotube, thermoelectric properties, nanowires, nanosensors, silicon-based FET devices, molecular device application, molecular device discovery applications, and homolumo visualizations for material science related elastic modules calculations, optimizations of the structures, batteries and energy storage applications, where you can simulate the lithium ion, lithium air, or light current calculations, phonon and heat transport calculations, thermoelectricities, thermoelectric transport properties, and many more properties can be calculated. Even vibrational modes can also be simulated. So it is not a single material specific. It is a software where it can work on molecular, polymers, materials, and device applications. All these things can be simulated under single umbrella. Now, what kind of materials and what kind of user interface and plugins are there? Its software having many molecular structure is already inbuilt, crystal structures, typical device structure, some interface structures, some device formation structure. That plugins is there where only you need to define the number of repetition structures or number of atoms, and it will within a single clicks or 2-3 clicks your structure will be automatically generated. You have no need to write any script, or any coding is not compulsory to write here. Either you want to generate the nanoribbon, nanotube, clusters, grain boundary, or random dopings, mixtures, alloys, whatever you want to create it. All these molecular crystals and nano device can be formed. Now here you can see the device modeling, crystal modeling, molecular modeling, spatial structures, any spatial structure that you would like to create, that can also be created. And you can import the material from online database as well as from third-party database. So we have the local import database is there for the materials, all 0-dimensional, 1-dimensional, 2-dimensional, 3-dimensional.
Ashwin sir,
Yes.
your slide is not changing, sir.
1 minute. There is some problem. Kindly wait for 1 minute. Let me change my network.
Now, okay, go ahead, sir. Hello.
Can you see now?
Now,
Yes,
Yes,
sir.
sir, visible. Yes, sir. Slide number 6, visible.
Okay. So now here you can simulate the typical device structure, graphene, nanoribbon, nanotube, whatever any complicated structure is there, it can definitely within a few minutes it can generate for you. Once I will see the live demo, then you will see that how you can simulate the multi-layered structures, monolayer, polylayers, or how you can bend the structures on particular angles, some repetitions, and many more things. Bonding will be done, dangling bond, armchair, zigzag, armchair, different type of graphene and carbon nanotubes can be created and simulated. Now, if you want to perform some doping also in some particular number of atoms, either N-type, P-type doping, or you want to define some mole fractions, concentrations, you want to create some alloys. So it is a very simple procedure that need to be followed, and based on that you can find different behavior of chemical structures. You can dope particular structure, create the alloy, and like there is indium arsenide material. If you want to substitute the gallium in between the indium arsenide, it is very easy to substitute the new materials to create the defect. Either you can create the defect by doping, by rotating the structures, rotating the atoms, or substitute the new atoms with increased doping and concentrations. So all these things you can substitute, and based on that you can find some electronic property as well as electrical properties. So that behavior we will understand it, and we will analyze after this live demo during that session, that how you can perform the various activity to create or simulate some certain materials. Now, if you want to create a device as well, apart from materials or molecular structures, you want to simulate some FET devices, GNR FET or carbon nanotube based FET devices, 2-terminal, 3-terminal or multi-terminal device can be simulated. So transistor option is there where you can apply the biasing voltage either on the source region, drain region, gate regions, and based on that you can find some transport properties, IV characteristics, and some transmission spectrums, and photocurrent analysis. So transistors analysis will also be there that users can easily be calculated. Okay, so transistor device is there where you can build the structures, you can define the number of atoms, and accordingly you can calculate its output analysis. Now, if you want to generate some various input file for modeling purpose, you want to generate some input file to run the calculations. So once suppose you imported the library, you imported some atomic structures, device structure, like there is some gold metals is there and some molecular structure is there in between, and again gold atomic structure is there. So you can create some electrode, anode, cathodes, you can define it, and then you can substitute the molecular structure in between to form the three terminal devices. So left electrode, center region, and right electrode. These are two terminal devices that anode cathode can be created with center regions. And then you can add the buffer layers in between, so it can be easily created. There is variety of file format that the software also support. If you have XYZ file format, CIF file format, HZW, POSCAR file format from BAS, or any other converter option is there. So the software can also convert the various input file which can supported in this software. So converter option is there which will convert it, and you can directly resume your work by uploading your existing work on this software. That's why the software is very unique and very easy to use and will definitely enhance your research to predict the property of material and devices. Now, whenever you will define some certain calculations parameters in density functional theory to simulate the material, you need to set some self-consistent parameters, either some electron temperatures, energy cutoff, exchange correlation functions, k-point sampling, and some contour integral parameters. So all options will be there. You can define the basic settings. You can define any temperature value, any cutoff energy cutoff range, exchange correlation functions. You can select linear combinations, LDA, GGA type, different hybrid functionals options is also there, and k-point sampling for the iteration control parameters. So that you can also set to define some linearity of the atomic structures. And next option in DFT calculation, that is called contour integral, where you can set the integral lower bound points, circle points, real axis density point analysis, infinite semi real axis value, and electrode temperature parameter. You can apply the voltage on left electrode, temperature on left electrode, key point number. Similarly for right electrode. So whenever your device is ready, you need to apply some voicing on that, and based on that voicing, you can find the IB characteristics. So you can apply some voicing as well, and it will calculate the electronic properties and electrical properties. So electrode, contour integral, basic settings, and iteration control parameters like density matrix parameter, Hamiltonian, total energy, mix Pooler methods, mixing variables, donor type, starting mode points, and relaxation is there. You can relax your structures using molecular dynamics or conjugated gradients options. Basis sets, you can define double zeta polarized, single zeta polarized, and different libraries also there for basis sets. So you can load the materials basis sets from our library, and you can also include some doping if you want to add some doping. So basic static parameter is there. User can also set your own parameter to define the basic sets. So, and it include the LDA plus Howard U terms corrections is there. So Howard U is also possible with spintronics calculations. Suppose you want to work on spintronics application, then spin parameter, linear, collinear, non-collinear spin type calculations that can also be performed for spin polarizations analysis. And once you will have done your modeling part, you have set all these calculations parameters, then you can generate the required input file to get it simulate. So these are some input file, SCF input file that will automatically generate once you will set various modeling part is ready, your calculations simulator part that you have well defined, Then this input file that is called scf.input that will generate for different electrode, left, right, and device region electrode will get it generate. So this is a process that we will do follow. Then it will goes to the analysis part. In the analysis, that what properties you can calculate, that is very important. Now, whenever you will ask about the device properties, because device is the unique feature for this software where you can calculate the electrical properties, IV characteristics, device density of state, effective potential, total energy, scattering states, transmissions, photocurrent, IV curve, charge, electron density, conductance, thermoelectric current, Seebeck coefficient. These are the device property, not a material. Material is having some different property that can also be calculated, like band structures and some density of states, electron density. So these are some material property that is separate part that will cover up in next slide. But here you can see the device property that can be calculated easily using this nano decal software from Nano Academic Technology. So if you want to calculate the potential, either effective potential, Hardy potential, action correlation potential, or neutral atomic potential, so what kind of potential analysis you want to perform, that can be predicted easily. And similarly, if you want to perform the transmission spectrum, then transmission spectrum, there are a lot of points, input parameters you need to set, and it can also calculate. And some IV calculations it can also perform. You can set various IV curve calculation parameter. You can select what analysis you want to perform, and it will select. You need to select from the simulator, and this is some user interface screenshot. So that analysis will help you from the user interface to calculate your output properties. And similarly, photocurrent analysis, if you want to perform for solar cell analysis, then this photocurrent photon absorption on your device, that analysis can also be calculated, where ion irradiated atoms, photon energy calculations, or polarizations, linear polarizations, or Boltzmann polarizations steps need to be defined, theta, phi, and all those things. Now, what properties majorly it can predict? If you talk about material properties, these are the material properties that you can predict: density of state, effective potential, total energies, band structures, charge, Hessian, photon band structure, electron density, potential, transmission channel, eigenstate, full band structure, effective mass, complex band structure, photon density of state, photon full band structure, photon transmission channel, modulus, ZT, and similarly the device property. I will show you the live demo that what are the how you can calculate all these properties using this nano decal softwares. So it is very broad software for nanomaterial and nano device calculations. Now there are some lot of papers are published using this software. So you can see here these are some paper which is published on molecular spintronics device calculation, spin polarized transmission through the single manganese pathologized molecules on CO nano.
Excuse me, sir.
Yes.
Still, sir, slide is not moving, sir. It is on the sixth slide only.
Uh, I don't know what is the issue here. Can you see this slide?
Yes, sir.
Fine. So there may be some network problem, or I don't know. I'm moving the slide from my side. So this software can work on different domain. Either you are working on spectronics applications or molecular devices, flexible devices, all electronics based applications it can get simulated. And even optoelectronic device you can also simulate it, and flexible probe devices. So this is all about capability. I will show you the live demo that will help you to understand properly. Now I want to show you the tool. 1 minute. Can you see this user interface of device studio? This is device studio on the top. So can you see my this lab dev tool? Can you see the tool?
But nothing is coming out at our screen.
Can you see the tool?
Yes, sir. Now it is visible.
Now.
Device studio.
Now.
Yes, yes. Okay,
Yes,
so
sir.
now I want to show you this tool instead of presentation. So live demo of the tool I want to show you. Now this is a user interface of the software. So can I continue? Can you see me? Hello.
Yes, sir, we can hear you.
Okay, fine. So let me continue. So now you can see the user interface of this device studio. So this is basically a software where we will do some modeling, we will do some calculation, we will set various parameters we will do here. Okay. Now let me take one material and would like to show you some properties. So first of all, I would like to import a material from my database. So I will click on file options and click on import button and click on import local. Can you see this import local option?
Yes, sir.
Yes, ma'am.
Fine. Now I would like to suppose take one simple material. Suppose I want to take one simple silicon and I want to calculate its property. Okay. We will do various manipulations later on. Initially, I would like to simulate this simple structure. Then we will simulate some complex structure later on. Now you can see here in the left side, silicon is loaded in my project. I have given the name of my project is called RTU, and inside this my project I have included the silicon material. That silicon materials you can visualize here. These are two silicon atoms are there that you can rotate and you can various manipulations will be done later on. First of all, I want to show you the calculations output. Now once the material is loaded, then I need to set the various calculation parameters. So that's why I go to the simulator options and will click on simulator nano decal, then SCF calculations. That is called simulator calculations parameter, where I need to tap define the electron temperature, energy cutoff, key point numbers, and all those things. So I will click on suppose key point number I want to define 4, 4, 4, n1, n2, n3. I want to define all these times 4 times repetitions. So I click on generate file. Now left side the scf.input file for this silicon crystal have got generated. So you can see here scf.input file in the left side. Now I need to go to the again simulator option where I will click on the nano decal and then go to the analysis part. Now what analysis I want to do, that I need to select from this analysis window. I will click on it and this analysis window will be opened. So I will click on band structure. Here you can define the symmetry K point U, X, G, gamma, and if you want to change this billion zone path, you can also change this billion zone path as per your requirement. You can add or delete. These options are provided to you. So billion zones path can be adjusted as per your requirement, and you can see the preview before click on generate. Now band structure is one output that I want to plot. Apart from that, if you want to plot electron density, then you can click on electron density. If you want to plot potential, transmission channel, then you can click on that eigenstates. So suppose you want to plot these output for the materials, rest of all. So rest of all you want to plot only these selected 5 property, and if you need to see what kind of electron density you want to see, either charge electron density, total electron, row, bond, distributed, lot of options are there. Similarly for potential, what kind of potentials and transmission channels options are there, and eigenstates options. So these are the analysis that I want to simulate, visualize. So I will click on generate file options. Now you can see on the left side, you can see there is one main input file scf.input. Other are analysis file, band structure, electron density, potential, transmission channel, and eigenstate. These are the output that we want to plot, and this is main calculations input file. So I will right click and select my machine to run locally. So this is a machine setting option which I can select it to run the locally on my computer. Instead of running remotely, I want to run the calculation locally. So right click on it and click on run button. This is run button to run the calculations. Here I need to set that how many number of nodes are there, how many cores are there in your server or workstation. So suppose I am having 4 core, that 4 core I want to run the calculation. I will define here and click on run button. Now the calculation is running as you can see on the taskbar. This is taskbar is showing that calculation is running. Similarly, I will run all the files so that one by one all my output file will be run sequentially. So I am running in queue in all these output analysis. So one by one, these all file will get it simulate. Now you can see first file that is called scf.input file has been finished the calculation. Second file is in running. Now second one is also has been finished. Third file is running condition. Similarly, next will be run this fourth file. Then one by one all file is automatically running. Once this file is running, then you can find the output file in this project window. So this is a project window. One by one the output will get generated. I hope this screen is visible to all the participants properly.
Yes, sir. Yes, sir.
Yes, sir.
That's great. Now you can see the calculation has been finished for all these steps. Now I want to show you the result for simple this silicon crystal structure. Okay. Now I wanted to simulate the band structure. So this band structure.xml file has got generated. So I will click on it and click on show view. Now you can see this is a band structure that has been generated for this silicon material. Now, if you want to zoom in particular regions, you can also draw the rectangles, or you can calculate that how much is the direct band gap, indirect band gap. And if you want to like export this data, this is export option is there. You can click on this arrow button that will help you to export your data in text format or in PNG format, JPG format. What format you want to export your output. So that's why you can plot in, you can import in other software. So it will export your data in text format and any format. Now it has been exported on the desktop. Similarly, this is band structure. If you want to plot electron density, now I can click on show view electron density. This is electron density graph where it is in 3-dimensional. That you can simulate, and you can see different isosurface planes or different color scheme is there. You can change the color. 3D model, you can visualize a 2-dimensional electron density as well. This is 2-dimensional, 3-dimensional, 1-dimensional structures, 1-dimensional electron density characteristics you can plot easily. So that's why multiple options are there. Either you can plot in 3-dimensional, you can plot in 2-dimensional, or 1-dimensional. And with color, different schemes option is there. Different color options are provided to you so that you can find as per your requirement, like that. Inverted and similar like that. And planar, different options are there. And you can also control your output characteristics in X direction, Y direction, Z directions. Similarly, in different planes, you can visualize the output. So this is for electron density analysis. And similarly, if you want to plot the effective potential, this is effective potential graph that you can plot. And different viewers are there, which planes you want to visualize your output. That's why the different 3D viewer planes are there. And similarly, effective potential in 2-dimensional and some 1-dimensional structures that you can plot. And transmission channel, if you want to plot transmission channel, this is transmission channel characteristics. Number of transmission channel, average over transverse case space, in negative and positive, and you can export the output in a standard format. So this is a simple structure that I have taken and show you some characteristics and eigenstates also similarly. This is eigenstates that you can plot, and 3-dimensional, 2-dimensional, and 1-dimensional. Different band value you can adjust. So that's why a lot of options are there. You can see this isosurface options. Now, this is for simple silicon material that I have imported and show you some output. Now, if you want to do some manipulations, you want to adjust the materials, you want to rotate, create the structures or different structures you want to create it. Then let me go to the next options. Now I have this silicon options is there. Now second one is called, there are some other materials is also there. Now you can see import local option is there. In the import local option, there are a lot of materials is already there in our directory. So this nano decal device studio is having a materials directory. So we have categorized the materials in 0-dimensional, amorphous, crystalline, different materials options are there. Polypropylene materials are there, polymer materials are there, crystalline materials are there, benzene materials are there, ethylene materials are there. All these molecules are there. So rubber or whatever the molecules you want to import. So this is a molecular 0-dimensional material is there. Either you can import the material from our local database. These are all 1-dimensional material for carbon nanotube, but multiple options can be created. There is also possible chance where you can manipulate the atomic structures. You can different manipulations. You can change as per your requirements. Similarly, two-dimensional material is there. Some nobility-based material, black phosphorus, hexagonal boron nitride, bismuth material, arsenide materials, graphene materials. This is graphene is there. Or three-dimensional material is also there. Conductor, insulator, layered material, magnetic material, metal oxide material, nobility material, semiconductor materials. Any material, whatever you want to use, that you can import from here. Suppose you want to import the gold, you can take it gold that is has got imported. Similarly, all materials can be imported from the local directory. So more than 500 materials is already there in our directory. Apart from that, suppose if any material is not present in the library, then there is another option that is called import online. So this import online will basically fetch the material through the API access from material project open source database. So material project is one open source library. From there it will fetch the material. Suppose you want to import MOS2, any material, not MOS2. So I will type the name of particular chemical formula of particular material and click on search option. This will search the material combinations from open source directory. So I click on it. It has provided a lot of options for MOS2 related combinations that you can see here. Once you will click on it, the materials are fetching from the materials project open source database. You can see its information also, that what will be the cell length, ABC value, alpha, beta, gamma value, atomic positions, atomic coordinate points. So that you can see here in this particular area, the atomic information of particular material. So not only molecule material, any material or molecule you want to import, either you can type some chemical formula. If it is properly spelled out, you can find it here. Suppose silicon, you can type it. It will give you all information related to that, like here. And then you can click on add button, that will get add into the stats. So now you can find these are two material which I have loaded it. Okay, now if you want to perform various activity inside that, you can find there is selection option is there, rotation option is there. You can rotate the atomic structures, you can zoom particular atomic positions, zoom in zoom out option is there. You can change the positions of particular this crystal structures. You can change the locations, or you can make it home screen. You can change on your earlier stage. There are different view option is there. You can change different planes. You can change the xy planes. You can change into YZ plane or ZX plane. So which planes you want to visualize, that's why different options are there. Similarly, you can fit it screen fit option, screen is there, so it will fit as per the screen option is there. Once you will click on it, it will fit according to the screen. Display option is there. If you want to see the display style, you want to change this lattice, you want to make it repeat in x direction, y directions, multiple direction you want to perform like that. So that's why these options are there, where you can make it repetition in any directions as per your requirements. And you can change color, display styles, atomic positions, lattice types, ball radius, stick radius. That's why this is display style that can be changed. Now apart from that, if you want to add some atoms, this is atom from periodic table can be added. Suppose you want to add some carbon atoms, you can click on this carbon.
Sir, you are not audible.
Hello, can you hear me?
Excuse me, sir.
Yes.
Yes, sir. In between, you
Yes,
were not
now
audible.
it's
Yes,
okay.
sir.
So I will take all your queries after this present demonstration. I will also check your question answer series in your type chat box. So kindly you can type your queries in between the chat box. I will go through after this live demo. Then we'll discuss on your queries as well. Now these are various options are there so that you can define. And now if you want to passivate your structure, passivation is there. Some different atomic delete, if you want to delete particular atoms, delete option is there. So this is very simple process that you can follow. Now if you want to create the interface, there is CAD option is there. If you want to import the, this is builder option where you can create the builder structures. You can click on CAD atoms and create the, add the interface in between two atoms. Suppose you want to add the atoms. And here we can select the material. Suppose you want to add gold and silicon interface. You can definitely easily done the interface between two materials. Calculate the grid size, spacing, stress, strain factors. Like that, you can see here that we can easily make the interface between the gold, silicon, or any other two material interface. If you want to create it, that is very simple step that need to be followed. And then we can click on build option. Now it has been created the interface between two different materials. Now if after that, if you want to change some certain positions, suppose you want to create a defect, you want to delete particular atoms, you can select it and then click on delete option. Now that will be deleted and it can create the defect. Or if you want to, instead of deleting, you can undo it and then you can perform on the replace option, replace with new atoms. So this is a new atom replacement that you can click and change with new atoms. So I will click on it, that particular new atoms, and it will change. So different colors are showing with different materials. Now if you want to create some different other type of defect, suppose you want to move the atoms. So if you want to perform some if you want to change some bond length between the atoms, so this bond length option is there. You can find the jet metric and you can participate and mute your mic. Now once I can select the two atoms, suppose you want to change the bond length between two atoms, I can draw the rectangle and then I can click on this edit atom with selected. So suppose you want to edit the bond length in between the atoms, that manually you can change the distance in between the two atoms and bond length can be changed. Similarly, if you want to change the angle, you can define the angle between two atoms so that it can get create such type of different effect. Now apart from that, if you want to create some you want to like rotate the atoms, so this rotation option is there. You can rotate along screen vector, along xyz positions, along abc vector positions. So this is options is given to you where you can different rotation with different angle option is also provided, so you can type particular angle value and it will get definitely rotate at particular directions. Suppose I want to rotate in this direction. Now you can see how this it is rotating, so that can be adjusted, and then you can click on previous condition. You can make it undo to go back into the last conditions. Okay, now these are other options are there where rotation mirror. If you want to create the mirror structure for suppose CMOS devices, there is NMOS, PMOS, or suppose you want to create an electrode where left electrode is having aluminum and right electrode is also having aluminum. So if you want to mirror such structures, so mirror option is there. You can create the mirror features. So modeling is very easy. Here you will not have to find any difficulty to create such a modeling. Okay. Apart from that mirror, there is some stretch option is there. You can set the stretch factor for the each unit cell vector that you can apply, and activate the strain tensors, strain and stress factors you can apply. Change the alternate axis, alternate coordinate points you can change x, y, z. Coordinate point you can change like ABC. If you want to change, you can click on it, ABC coordinate point, it will be changed. Similarly, XYZ location, it can also get changed here if you will change these positions like that. Now these are certain options you can wrap along the A condition, B condition, C condition. So which direction you want to wrap this structure, accordingly wrapping is can be done. And some center position, if you want to make particular center, instead of creating some left scattering regions or left unit cell, you want to make your unit cell in the center region in B side, A side and C side, then or hold the side, you can make it center position, so the atomic position will be on the center side. And other option is there, fit cell. If you want to fit your atomic structure in the unit cell, you want to fit in A direction, B direction, C direction, so that fit option is there, that it will fit, that will adjust in your unit cell. So it is like adjustment in the unit cell. And if you want to convert into the molecule, you can click on this convert to molecule option. Once you will click on it, the unit cell will be removed. Now I click on it and unit cell has been removed and it can become as a molecule. Unit cell has been gone. You can click on undo, then it will come again back on the previous conditions. And now if you want to convert, again undo redo option is there. If you want to convert molecule into the crystal, so now it is a molecule, and this molecule you want to become make a crystal, then you can click on this convert to crystal option is there, where you need to define that Bravais lattice. Either it is simple, cubic, FCC, BCC, rhombohedral, hexagonal, triclinic, FCC, and user defined Bravais lattice can also be defined. So it is support all type of lattice parameters, and you can see the preview option before it build. You can see the preview, ABC, alpha, beta, gamma, primitive vectors, all these things you can visualize. Like you can see here, whatever type it is, you can adjust as per your requirements. And then you can click on build condition, that will make it build. Okay. Now other option is there if you want to make it a device. So this is device option. If you want to create the electrode, left electrode, right electrode, or bottom electrode, top electrode, front electrode, back electrode, multiple electrode, 6 probe device can also be get simulated. So multi-probe device structure, you need to define the X, Y, Z coordinate point. I will take one example of electrode as well that I want to will show you. Initially, we need to define the exact coordinate point to create your structure properly. Now, if you want to measure the distance, there is a distance measure tool is there. So suppose you want to measure the distance. This is distance measure tool. Suppose you want to measure distance from this atom to this atom. These two atoms in between, you want to measure the distance. This distance can be measured around 7.909 angstrom from this carbon atom, silicon atom to gold atom. So any two distance measure distance can also be measured. This is atomic distance measurement tool. And if you want to measure the angle, this is angle measurement. If you want to measure the angle, like suppose you want to measure the angle between these three atoms. If I click on it, you can find this how much is the angle in between three angles. So it can be easily get measured the angle automatically. Like that. 85 degrees something. So angle measurement, distance measurement, dihedral measurement, suppose plane to plane measurement. From one plane to another plane, you want to measure the angle. So this is dihedral plane measurement. So similarly, if you want to measure the plane to plane measurement, then it can also measure the angle between the planes. So that's why this is plane measurement. Dihedral option is there, that can also get measured from one plane to another plane. Similarly, vector measurement tool is there. You can measure the vector, AB vector in between two atomic structures. So this is like AB vector that you can measure. And linker bond calculation is there. If you want to calculate the linker, this is linker bond. So that will also get enabled. So this is all toolbar option that will help you to manipulate the structures to make your desired structures, to create the structure as per your requirements. Now, apart from that, there is one more option is there in the builder option. If you want to create some interface, there is interface builder option is there. You can convert the structure to the device. You can create the device structure directly. If you want to redefine the crystal structure, you can create the crystal also here. This is crystal. You can define different space group option is there. You can choose the space group as per your requirement. Lot of space group option is there. You can define the ABC value here, and primitive cell vector, that fractional coordinate point. You can add the fractional coordinate point, primitive cells, conventional cells. You can check the preview options, and then you can also create on build option to build your atomic structures, crystal structures. So this is a crystal maker that will help you to build your crystal structure and sell the primitive and other options. And you can see the symmetry operation x by z minus x minus by z. Space group details can also be visualized, and then you can also click on build if you want to build the structures in the builder options. Now if you want to create some suppose you want to repeat the structure, there is redefined crystal is there. You want to define the crystal in transport direction, suppose 8 times. So I have click on this 8 time in the C transport direction and click on preview button. This is preview button where 8 times I have repeated this unit cell on in C direction. If you want to repeat in B direction also, then you can increase this number of V, and then you can see the preview. Now this is preview button. And then similarly, if you A condition, you want to make it repeat, then all condition it will get repeat. So you can see here multiple options it can get created. Then we can click on builder. So this is a builder where we can see that what kind of structures you want to create, you want to model. So that need to be created by the user as per your requirements. Now if you want to make some surface, this is surface slab option is there. If you want to define some mirror indices, HKL value, and some different planes. So this is mirror indices 100, 110, which planes you want to create some surface. So this is surface option is there. You can find all elements value p1, p2, p3 coordinate point, and you can create the surface primitive cell vector. Define the vacuum if you want to create some vacuum also. This vacuum slab and its thickness you can also adjust as per your requirements. So this is just to create the surface, and it will create the 100 surface slab as well. Okay, this is now surface. Lot of other builder option is there, which you can build the structure easily. Interface builder is there. Convert to device, bending of device structure. You want to bend the device, that option is also there. Decomposition, if you want to create some molecule, this is molecule option is there. Suppose you want to create some H2O molecule, so you can give some, like here the different coordinate point. And here XYZ position, once we have defined properly, then we can also see this preview option for molecular builder. So this is basically a molecular builder which we can build the molecular structure easily. I can take you one molecular builder structure. This is a molecule that is created from the same molecular builder by providing the accurate points. Once we define the proper accurate point, the molecular builder can be created easily. So this is like H2O molecule or any molecule, not only H2, that can easily created, and we can find its property, like you want to see the XYZ or some ABC value, vector coordinate point, all these things can be visualized. Number of atoms, total area of lattice, that we can visualize here on the screen. Now if you want to create some graphene nanoribbon based plugin is also there. So if you want to simulate some graphene based carbon based nanoribbon, you can click on it, and you can also select some material from the periodic table. So we can select from here, and then we can click on OK. Now here bond length option is there, and passivation with dangling bond option is there. Kral vector, N and M value we can define. So which type of like graphene nanoribbon you want to create, either zigzag, armchair, zigzag. According to that, you can define this N and M value, and you can click on preview button. That will generate the graphene nanoribbon options, and click on build option. It will get generated here. So the building part is very easy. The user interface will help you to quickly generate the structure for nanomaterials. Similarly, nanotube option is there, where you can also simulate different kind of nanotubes. Option is there that you can click and generate it like that. You can also substitute the new material inside this nanotube or graphene. Now you can see here that is very easy to make such a typical structure. Even though if you want to create some device structure, you can create the device as well. Suppose you want to create some different complicated device structure, some left and right material, two material, you want to create some different interface, left, center, right kind of structure you want to build. So this option are bottom and top structure. There is one material on bottom, second one is on top. One material in bottom, center, top, front material, back material. That kind of structure, different plugins are there. So you can easily create such a device. Suppose you want to create this left and right. So here we need to select the material, left material and right material. Suppose silicon and gold you want to select, and this is surface vector. You can see the preview for this one, and find some Mismatching can also be calculated. That how much is the mismatch between these two atoms. So this is a left and right kind of plugins structure is there. Now, apart from that, there are a lot of other plugins option is there that can also be similarly get it create. So whatever kind of structure you want to create, you can click on it and you can create on it. Okay, here we need to select different materials and it will get. Now I am selecting here. Suppose these are different three materials with their surface vector. See the preview button. So left and center regions mismatching, distance mismatching. So any complicated structure is definitely very easy to create here. So this is a modeling part. Now apart from that, if you want to simulate some disordered type graphene structure, super cell structure, this is disorder type can be easily created. You can define different site A value, site B value, its bond length, and you can get it create easily. Apart from that, there is a convert file option is there. Once you will, if you want to convert your BAS file, ATK file or Gaussian file, this convert option is there that will convert your existing file in HZW or XYZ file format so that you can resume your work instead of building your materials structure from scratch. You can directly resume from your existing work so that your existing file get it convert and you can directly focus on your research. So convert option is there where any format it can get convert and it can directly be imported in this device studio. So this builder option is definitely help you in every condition. Now let me import one material for device as well and want to show you some other functionality. So this is a device option is there where left electrode is there, right electrode is there. In that, if you want to perform some bending, you want to bend the one side or other side. So this option will not be available in any other software. Any software, this bending function will not be there. You cannot bend the structure in any software. So either one side you can bend by particular angle, theta or radius. You can select it and see the preview. Now you can see here that how the flexible device can be simulated. So this is a flexible structure. So you can flex, make your carbon nanotube, graphene, molecular tunnel junctions, magnetic tunnel junctions, any structures you can make it either one direction bending or both direction bending. You can perform it like that. So this is bending, and you can see how if you will bend the structure on particular angle, then how the device performance will be hampered. So that's why these are advanced functionality that you can get inside this device studio nanodical software. Now this is basically a modeling part that can be performed. Now next option is goes to the simulator one. So this simulator is basically a calculation engine. Till now you have learned the modeling part, modeling of material, modeling of interfaces, modeling of device structures. Now you will learn now to see the calculation part, simulations, theoretical background calculations parameter. So basically in the simulator, you can find this nano decal option that we are going to represent today. So here there are a lot of options are there. 1 minute, let me show you the all option enabled. There is an interface with third-party database. BASP interface is there, LAMPS interface is there. This is visualizations, own visualizations tool is there. And this is a quantum espresso interface is there. Gaussian interface is there, NewCam interface is there. So all software having interface with this device studio. So that's why this is a unique software. Unique software where all interface calculation will be there, and along with that own calculation engine is also there. Now here you can find this SCF calculation parameter. In the SCF calculation parameter, you can see here, before SCF calculation, you can also see one more function that I want to represent to you, that is called BCA. That is called virtual crystal approximation. This is basically to create the alloy. Suppose you want to create a alloy with you want to substitute the n-type doping, p-type doping. You want to define some mole fractions. In that condition, there is n-type, p-type doping option is there, and you can define its concentration in percentage. So this is basically for type of dopant. If you want to create a mixture type atom, instead of vacancy creating the vacancy, you want to include the atom mixture. In that case, composition option is there, that how much compositions like X, 1 minus X, indium gallium arsenide. So this mixture atom compositions you can also define with that, and then you can click on generate option. So with different option, it will generate the BCA, virtual crystal approximation, to create the alloy. Now that's why these are all options are there. Help option is also there to take some help for this device studio. Now relaxation option is there. If you want to relax your atomic structure, this relaxation option is there, where you can relax using the molecular dynamics and conjugated gradient, CG and MD. Both options are there. Force convergence criteria. You can optimize your structures. Basic setting parameters are there, iteration control parameters, and different exchange correlation functions. LDA, GGA with PBE exchange correlation functions are there. So you can choose what type of exchange correlation functions is required for your calculation parameter. That you can set. Relax parameter, iteration control parameter. You can set the density matrix, Hamiltonian, total energy parameter, mix method, and different mixing variable and Hamiltonian real space density matrix parameter is there. Basic sets are there. LDA plus U, Howard U terms calculations, double zeta polarized, single zeta polarized, user defined basis set is also possible. Some neutral atomic database or material MATLAB project based database. This is a neutral atomic database is also there, so you can take the basis sets from our library. So mostly all material library is there where this database is there. So you can import the database from our library. Now, if you want to perform the spintronics calculation, there is without spin, collinear spin, and general spin. Sorry. Now here the collinear spin is there. You can define the spin polarizations. You can define the rho value, or you can define some spin orbit couplings, spin orbit theta, phi, all these things you can activate as per your requirement for spintronics calculations basically. So before performing the calculation, you can also relax your structures, variable cell relaxation. So that's why the simulator option is there for crystals and molecules. If you want to simulate the device structure, I can show you the device functionality as well. Like this is a device. If you want to simulate the 3-terminal transistors, you can add the buffer. This is buffer layer where you can add the buffer condition. You can add left buffer, right buffer conditions. You can check it preview with that buffer condition. How much is the buffer regions in that? So you can adjust as per your requirement the buffer region, and then you can click on build. Otherwise you can go to the simulator option and you can click on the transistors. Now for the transistors FET devices, nano FET devices, there is a gate region is there, permittivity you can define, dielectric thickness, channel regions, number of gates. If gate region is there, otherwise anode cathode will be there. You can define the source, left region, right region, and apply the biasing also, and gate region side information. IB characteristics, K point number you need to activate. Basic settings are there similarly, all basic settings. Contour integral parameters are there. And electrode option is there, left electrode, right electrode. So these are the options for device functionality. So since the simulation requires some good computer and it also takes some lot of time to get it simulated. So that's why I will not going to simulate here. And this is a doping option is there. If you want to make some doping, the user defined basis sets is there. You can define the doping atom indices. You can include it in the basis sets. You can include the doping type atomic indices so that you can add the doping atoms by enabling this doping functions, and you can generate the files required file to get it simulated. And this is for spintronics. Then you can click on generate file. Now different files has got generated. For different vice voltage it can generate the without vicing, no gate voltage, with gate voltage particular 0.1 value, 0.2 value, 0.3 value, different value, the different input file will get generated, and you can run the simulations all file in a single click. So that's why the device functions is showing here, left electrode, right electrode, or electrode calculations can also be performed. So this material, this nanodecal is basically an alternative option of quantum based virtual nano lab, because it is developed by previous founder who worked earlier in NTK from 2008, and they were developing this software in parallelly. So that's why the software is quite useful with a lot of advantages is there in terms of this third party interface option, bending of device structure option, interface builder is there. If you want to see the interface builder, this is interface builder option is there. You can also make it interface. So this is basically interface builder. If you want to make it the interface, different strain with first surface, second surface, both the surface. You can calculate the matching like that. You can see the preview and see this number of angles, number of atoms, strains, how much is the mismatching, rotations, angles, mean absolute strain regions option. So this is called interface builder, where you can create the interface also. Like here, this interface for the graphene layer has got generated like that. So you can make the desired structure as per your requirement. It is very simple modular, where you can simulate, you can create different options are provided to you. Even CAD based design can also be created. And if you want to simulate the nanowires, so nanowire option is also there. Suppose you want to simulate the nanowire, I want to create the surface, then it will enable the nanowire. So nanowire grain boundary, this is like grain boundary, sigma axis grain boundary conditions, different options are there. Theta, you can see the different grain boundary condition, and some nanowire, you can define the wire direction conditions in x y directions, 1 1 1 1 0 0 and 1 1 0 radius, cluster radius, surface energy. So nanowire can also get it simulate. That's why the software is very user interface. And zinc blend type, icosaedron, cubooctahedron, whatever type of unit cell you want to create it can definitely create such type of polarine or whatever you want to create. Now this is all about modeling part. Similarly, simulation part is this one, where you can use this. Nanodecal is basically for device calculation, quantum transport. If you want to work on only large scale real space atomic structure calculation, then rescue is another software that we have for large atomic structure calculation on real space atomic positions, where density functional perturbation theory is there. Perturbation theory that can also be get included. So you can also Raman spec property calculation basically, where this software can also rescue software is there that can generate the Raman factors, Raman calculations. Okay. So these are all basically, these are different other software for tight binding calculation. Nanoskim is there for different topography or nudge elastic bend, projected augmented wave kind of analysis. These are different other tools are there. Now let me take you one interface structure also. Suppose you want to simulate one interface. Let me take create one simple interface between two material. This is already basically generated the structure like silicon and gold. I can take it here. We can define its length, its distance. Click on build option and then click on generate options. Now let it simulate this structure. So I can click on this scf.input file and click on run button. Now it is in running condition. If you see on the bottom last one is in running condition, that is getting simulating. And we can go to the analysis part and click on band structure and click on generate file and click on run button to run parallelly. So first this second last from the bottom is running, and last one will automatically get started once second last got finished. So fill junction, this one project is getting running. All this information we can see. So to simulate a large number of atoms, it is required some time, because it requires some good computer as well as some time as well, because the atomic structure is definitely required the time. Here you can see that how many number of atoms are there, how much the total area of this unit cell lattice there, that we can also see here. So that's why it is very easy. Now it got finished, and density of states band structure is got generated. We can click on show view. Now you can see the band structure for this new structure. So that's why you can see here today you have learned that how you can do the material modeling, interface modeling, device modeling. Suppose you want to simulate the density of states also. So let me try to analysis the DOS. I click on density of state, then click on generate file, and then click on density of state, click on run button. Now last one is getting running. It has got finished. Let's see if something comes. Actually, we have not defined the accurate point, so it is showing on the bottom of the screen. Here it is showing 0 value only. There may be something parameter may be missing. That's why this DOS is not plotting. But all options, whatever you want to plot, that you can click on simulator, nano decal, analysis part, and whatever you want to plot, you can click on it, and you can click on generate. This is machine setting. You can create the machine, you can run the job locally, remotely, like that. Different options are there to run the cluster calculations. So this is electron density, similarly, like that. In 3-dimensional model, 2-dimensional, or in 1-dimensional. All graphs you can visualize, you can zoom in and export the graphs. From my side, I have tried to all the features. Now I will look into all your queries and I will answer you that how the software can beneficial. So now if I checking your this query session, so 1 minute.
So one of the participants have asked, is the device studio software free for download?
No, it is not free for download. It is a commercial software that need to be purchased.
Participants, you can ask your queries.
So Device Studio is commercial and it need to be purchased. So you can contact to us if you're any participant is required anything, then you can kindly contact. We can give you some offers or something like.
Yes,
Now
and
you can
demo
ask.
session is always there with such softwares. Is such so with this?
Yes, this software demo version is also there, so we can also provide you. For the interested user, the demo version can be provided if you are really interested.
Okay. So participants, if you are having any query, either post in the chat box or you can directly ask with the speaker.
So from my side, thank you to all the participants to listening and to organize this session by Dr. Sanju Tanwar. I really thanks to them. And now we have 15-20 minutes that you can ask your queries, please.
How to buy?
So for buying a case, you can contact to our email address. I can share you my details on this chat box. You can drop an email. You can contact on my cell number so that I can discuss about your requirement. And based on your requirement, we have different options. We have 1 year license, 3 year license, permanent license. So based on your requirement and budget, we have different policies. So we can give you the offer. You can drop an email or you can contact on my cell number I have given in the chat box.
So what is the basic cost of this software?
So the cost of the software, for single permanent license, will cost around 6 to 6.5 lakh. Single permanent 6 to 6.5 lakh. If you will go for 1 year license, that will cost around 2.5 lakhs for 1 year.
So, how many users may be used this?
1 year cost around 6.5 lakh for permanent. If you will go for multiple license, like 2 license can cost around 10 lakhs, and for 5 license can cost around 12-13 lakhs. In 12 and 13 lakhs, you can get 5 license for permanent.
Any other query? Okay, in that case, thank you so much, Mr. Anil Sharma, for the presentation. I think all the participants will definitely get to know that how the simulation can be done through the software, and we can create the different type of nanomaterials and see the characteristics of them. So thank you so much, sir, for joining the session.
Thank you. Thank you from my
Actually, I
side.
am not able to access the chat box.
Yes, sir. Can you repeat?
Ma'am, actually, I am not able to access the chat box.
The chat box. So
So
maybe
you
some
can,
problem on
if you
your
have
screen.
if you have any query, you can ask your queries directly.
Are you accessing from mobile phone? Are you on
Yes,
mobile
yes.
phone, sir? I can help you out.
Yes, I am on mobile phone.
Okay, if you're on mobile phone, just tap on your screen and see on the top. You must find a chat box. Two links are there. One is for the group of people and another one is for the chat box.
Actually, I have done that thing, but it is not working.
Okay, sir.
Okay,
So
so there
actually,
is a
my
one
question
query.
is,
One query. Can we find the electrical conductivity and other properties using this software?
Yes, definitely. It is completely all electronic and electrical property can be calculated.
Is there any other free software for nanometers design purposes?
Yes, Quantum Expresso is there. That is free. Anyone can use Quantum Expresso.
Okay.
so sir, my question is here, can we check the change in electron affinity in presence of different gas molecules on the surface by this software?
Like affinity analysis, electron affinity.
Yes, yes, sir.
That I'm not sure about it, but there
Like
will be one.
actually we are working in gas sensing, so we have to check whether the material is sensitive toward that particular target gas or not, or how much sensitive it is. So in that respect, if we want to simulate few materials, so is it possible?
So actually, I'm not sure about that, but you can do one thing. You can drop me the email so that I can ask the developer of the software. They can much more clear about your questions. So you can
Okay.
elaborate in details in your email and send me on my email ID so that I can ask to my developer who has developed this tool, and you can see my contact detail on the screen. On the screen, my email ID and cell number is there where you can drop your email in details so that I can forward it to my higher authority.
Actually, sir, I am not able to access the chat box, even the screen
Okay,
also.
wait a second, participants. Okay, sir, thank you for the presentation. You can leave if you want. Dear participants, the chat box is there. Check out your, if you are on the mobile, then on the mobile right hand side, in the upside, there is coming one circular box that is a chat box. Or you can open the same link on the browser also, where you can see in the downside there is a chat box near to the participants symbol.
Guest, excellence, very excellent presentation. ये संजू का नंबर का क्या FDP है संजू का नंबर ये फीडबैक निकलेगा ये क्या ओपन करूं